Hello! In this video we're going to attempt to find the domains of combinations of functions, including arithmetic combinations and compositions. If I go too quickly for you, you can go ahead and slow down the video. If I'm going too slow for you, you can speed up the video. Let's start with these two functions, x to the 3 halves and square root of x minus 3. We're asked to find the formula for f divided by g of x and then simplify. So let's see if we can do that. F over g of x means we want the numerator to be our f of x function, the denominator to be our g of x function. So in this case we have x to the 3 halves in the numerator, square root of x minus 3 in the denominator. Let's see if we can simplify it a touch. So x to the 3 halves can be written as the square root, that's what the 2 means, of x to the 3rd power. We can either write the 3 inside with our x or outside as I did, divided by x minus 3 in a square root. Now, we can't really simplify this any further, so now let's examine what the domain of the new function will be. So first let's look at the domain of f of x, which in our case is the square root of x cubed. So we know that a square root function can take 0, because square root of 0 is 0, and it can take positive values. But it cannot take negative values since the implied domain that we're working with here is the set of reals. And so the domain here is going to be 0 to infinity. Let's put this first on a number line. So we're going to have 0 inclusive all the way to infinity. Let's examine now the domain of g of x. Now our g of x function is the square root of x minus 3. So again, we want the input to take on values that are greater than or equal to 0. Now the problem is that our g of x is here in the denominator. So in this case, we're going to state only that x minus 3 should be strictly greater than 0. What that leaves us with is that x should be strictly greater than 3. Plotting 3 on our number line, so here's my 0, here's my 3, I have strictly greater, so open parentheses, and then greater than 3. Now if I now have to examine what the domain is going to be of the new function, then the question I'm asking essentially is, what is the domain of this whole thing? Well, I need to look at what is the most restrictive. If I choose, for example, the value 1, which is just after 0, and I substitute that into the square root of x, the square root of 1 is 1, cubed is 1, that's not a problem. However, if I input 1 into my g of x function, I get a negative 2, which is a problem for a square root of negative 2, which is non-real. So I'm going to end up going with my most restrictive, which in this case is 3 to infinity. That will cover all of my bases. So the domain of f divided by g of x is going to be non-inclusive 3 up to infinity. Also not included at the endpoint. Okay, let's try something else. So in this example, we have another square root function and then a rational function, which we have yet to see. So let's see how we can compose the two of them. So f of g of x. This means we are composing our function f and g. Now we're going to start with our g of x function and we're going to input it into the f function. What that means is we're taking this x minus 5 divided by 3 and putting it in wherever we see an x into our f function. And so we have the square root of x minus 5 divided by 3 plus 4. Let's make that just a touch clearer. Okay, so now let's examine what the domain of this new function would be. Okay, so there's two things that you need to consider again. So we need to consider that right here we input the g of x function, which was this one. The g of x function, x minus 5 divided by 3. Does it have restrictions? Are there any x values that I can input that I won't be able to subtract 5 and then divide by 3? It does not. Okay, and therefore we would say the domain of g of x is all real numbers. Okay, so far we're not terribly restricted. That was us looking at the input function. Now we're going to examine our f of g of x function, which we have found to be this x minus 5 divided by 3 plus 4, all under a square root. We know that the inside of our square root will need to be greater than or equal to 0. Since x minus 5 divided by 3 plus 4 has to be greater than or equal to 0, that means that x minus 5 divided by 3 has to be greater than or equal to negative 4. We'll multiply both sides by a 3. Okay, since we're multiplying by a positive value, we don't need to switch our inequality sign. That gives us x minus 5 is greater than or equal to negative 12. Adding a 5 to both sides gives us x is greater than or equal to negative 7, which means that, all in all, our domain for this composition of functions is going to be negative 7, comma, infinity. Now, why did we not have to consider our g of x? It's because it had no restrictions to begin with. Okay.